Good morning to all of you students. Today we are going to
Morning, sir.
discuss bond and development length in concrete. Students, as you might be knowing, when we introduce reinforcement within the concrete body because of the hydration reaction between the cement and water, one sort of homogeneous paste is prepared. Concrete, when it gets set and the bars are reinforced, then there exists bondage between steel and concrete. This bonding means some sort of attractive type of forces, right? This bonding between steel and concrete is very important. More the bond perfect will be, the more serviceable the structure will be. So actually, in order to have proper bonding between the reinforcement or steel bars and concrete, we provide some specific length that we call it as development length in steel reinforcement. So what exactly the development length is, and this development length is provided actually to ensure good bond between concrete and steel bars. There should not be slippage of reinforcing bars and concrete. So I shall show you one image. You please look at this image. In this, it will be clear that what exactly the development length is. If you will look at this image, see here, it is quite obvious that these are the reinforcements, right? I shall open my marker pen and so that I can give you a good view. So let us see here. This is reinforcement. See this, these are the steel bars. Now these are also the steel bars. These are, this you can call it as top steel, top reinforcement in beams. This you may call it as bottom reinforcement, right? I am abbreviating BR. It is not a standard abbreviation, but this is bottom reinforcement. This is top reinforcement. This is the actual image how the reinforcement is introduced. Now if you will look at this portion, see, carefully observe this portion, right? These bars are bent and then further they are increased till this level. So this length is known as development length, and we abbreviate it as LD, or you can abbreviate it as LD, development length. I shall try to show you few more images. Lot of images are here for the development length. You see this image. I shall try to zoom it. You see this. Here also you will get a good image. See, in this image clearly it is mentioned development length, right? So this is the beam, this is the reinforcement or cage of the reinforcement. And see how these bars are bent. So this is development length. So I hope that with the help of these images, the concept of development length, looking at these images is clear to you, all of you.
Yes,
So
sir.
this development length actually gives good bond. It gives very good bond between the concrete and steel bars. Now, what are the provisions made by Indian Standard Code of Practices for providing the development length? Now, please note, I am referring to IS 456 2000, and for bonding and development length of bars, you have to refer class 26.2.1, page number 42. Now see this equation. See this equation. If you will look at this equation, you will observe this LD. This LD is development length. It is clearly mentioned in IS code. Phi. Phi is nominal diameter of the bar. This is rho S. So it is the stress in bar at the section considered at design load. In simple words, you can say it is sigma st, stress in steel under tension. 4 is a constant value and tau BD is the design bond stress. Now to determine the development length, you know the diameter of the bar. As you are working on site, you know what is the dia of the reinforcement. Sigma st value I have told you. You can easily get the stresses from Indian Standard Code of Practices. Now what about tau BD, that is design bond stress? For design bond stress, you have to refer page number 43 of IS 456 2000. In 26.2.1.1, you all of you have IS code now. You can refer after my class. If you look at this table, the various grades of concrete are given: M20, M25, M30, M35, M40 and above high grade concretes. So design bond stress value, you have to take 1.2 if your concrete grade is M20. You have to take 1.4 for M25, 1.5 for M30, 1.7 for M35. Like this, it is quite obvious that the design bond stress values are given. But you have to remember and you have to observe this clause carefully. In GATE exam also, many a times this question is being asked. For deformed bars conforming to IS 1786, these values shall be increased by 60%. For bars in compression, the values of bond stress for bars in tensile tension shall be increased by 25%. And if you wish to design by working stress method, the value of bond stress tau BD is given in annexure B 2.1. So these are the most important objectives for GATE exam that if you want to calculate the development length, then the design bond stress values has to be increased for deform bars Fe415 and Fe500 by 60%. Means if you are using Fe415 and Fe500, you have to multiply 1.2 by 1.6 because you have to increase the values by 60%. And the same reinforcement if you are using in compression, right, then it has to be further increased by 25%, means it has to be increased by 1.25. So these are the clauses which you have to remember, and you have to take choose the value of design bond stress from this table, and you can easily calculate the development length because you have to choose the value of bond stress only. Sigma st, sigma s, or stress in bar at section you have with you. In this way you can calculate the development length. So this is all about the development length and design bond stresses. If you will look at this figure, in this figure also these cracks are shown. If it is subjected to UDL, you will get such types of diagonal cracks, and it is very important to provide the development length to ensure good bondage. So that is the gist of this development length and bond stress. Now if you will look at this, how the anchors in reinforcing bars are provided, how the bars are anchored, and this anchoring of bars is done in the combination of development length to maintain the integrity of structure. You please see this. This is, I have incorporated these standard figures in my slide so that you can see the standard hook. Now I have enumerated all the salient points in this slide. First point is deform bars may not need end anchorages if the development length requirement is satisfied. The development length you have calculated, you can provide, and the length criteria is satisfied, then no need of end anchorages is there. But despite of providing the development length, still the criteria is not satisfied, then end anchorages has to be provided. Hooks should always be normally be provided for plain bars. It's obvious that is intention. And apart from IS 456, you can refer standard practice SP16 code to refer the clauses mentioned in IS 456. That will give you clear picture of IS 456. So standard practices should be referred along with IS 456 or IS codes. So for IS along with IS 456, you please refer SP16. And few clauses I have mentioned here, that the anchorage value of standard bend shall be considered 4 times the diameter of bars. Anchorage value of standard U-type hook shall be 16 times the diameter of bar. These are the most important objectives for GATE exams, which are already available in IS code. So students, this is all about the bond stress and development length. I hope you might have enjoyed today. Thank you very much students. Thank you.